Okay, students, good morning. Today, the new chapter is in mechanics, laws of motion, Newton's laws of motion. Let's go. In mechanics, it is one of the important Newton's laws of motion. So generally it is called as laws of motion or Newton's laws of motion. In laws of motion, first we know what is inertia. Inertia means resistance. That means inertia is the inability of a body to change its state. The state may be rest, the state may be in motion or uniform motion or accelerated motion. That is called inertia. Right. First one. Inertia. Resistance to change. The inability of a body to change its state of rest or uniform motion is called inertia. Okay, first this is introduction. The inability of a body to change its state of rest or uniform motion. So, resistance to change, it is not interested. So that initial state. Suppose the body is initially at rest. It is not interested to change from rest to motion. That is called inertia. Now, mass is the measure of motion. Inertia is the property of the body. The inertia having every body, that is the property of the body. Inertia, mass is the measure of motion. For heavy mass, more inertia. For low mass, less inertia. Inertia, mass, both are proportional. Next, types of inertia. First one, inertia of rest. Second one, inertia of motion. Third one, inertia of direction. Inertia of rest, to change the inability of the body to change its state of rest. State of rest. Suppose a person standing in a bus. A person standing in a bus. So the bus is moving suddenly. The bus starts suddenly. Now in the bus the standing person, so the standing person push backward because of he is unable to change instantly. He is unable to change its state of rest instantly. That is called inertia of rest. Inertia of motion, the inability of a body to change its state of motion. Suppose a bus, in a running bus, a bus is moving so with a constant velocity. A person standing in the bus, the driver so applies sudden brakes. Then the standing person in the bus are unable to change its motion instantly. Then he push, so he fall forward direction. That is called inertia of motion. Inertia of direction, the inability of a body to change its direction. Suppose a bus, a running bus is moving with constant velocity, suddenly turns from right to left. Then the persons, the passengers which are present in the bus are thrown outward because of those are unable to change its direction instantly. That is called inertia of rest, inertia of motion, inertia of direction. Right. First one, inertia of rest. The inability of a body to change its state of rest is called inertia of rest. Simply say that inertia is laziness. Lazy. It is resistance to change its state. Next. Second one. Inertia of motion. The inability of a body to change its state of motion. Is called next. Inertia of direction. The inability of the body to change its state of direction is called inertia. That is inertia. Okay. Inertia, types of inertia. Now we go for another physical quantity, momentum. What is momentum? First, before that, Newton's first law of motion. What is Newton's first law of motion? What he says, Newton's first. Same. Newton's first law says that about inertia. every body, initially, in universal, every body in its state of rest or uniform motion. Unless, until it is acted upon some external force. Some external force, until it is acted upon by some external force, everybody in the universe in its initial state of, in its initial state, the state may be rest, the state may be in motion. Suppose the board is hanging here. Unless it's external force acting on board, the board is always, the position does not change. The position of the board here only. Here only. That means, that is called first law of Newton's first law. Every body in its state of rest or uniform motion, unless it is acted upon by some external force. It's called Newton's first law of motion. Newton's first law tells that about inertia. Simply said. Right. Next, we go for another one, momentum. What is momentum? What is its application? Say, momentum P. Wow. Momentum is a vector. The product of mass of the body and velocity and its velocity is called momentum. The momentum is calculated when the body is in its motion. Suppose the body is at rest, velocity 0, momentum 0. The body of momentum is measured when the body is in motion. So that may be in uniform or non-uniform or accelerated. Right. That is momentum. The product of mass and its velocity is called Neet. Next one. Momentum is P bar is equal to mv. Momentum is vector. SI unit kg meter per second. Diameter for m L power 1 T power minus 1. Next applications. That is about momentum. What are the applications of momentum? Momentum applications. First, what is change in momentum? Change in momentum. Delta is equal to P2 minus P. The change in momentum is always present between modulus. The momentum, change in momentum may be positive, may be negative, may be zero. But we have taken positive or negative according to condition. Delta P is equal to P2 minus P. What is that? Delta P is equal to mV2 minus mV1. Delta P is equal to m of V2 minus V. Next one. Next one. If a body is moving with initial velocity v1, after its velocity changes v1 to v, makes an angle theta. Yes, its direction changes. Then what is the change in momentum? P1 is equal to mv1, P2 is equal to mv2. Angle between is theta. Delta P is equal to P2 minus P1. Delta P of mod S is equal to root over P2 minus P1. We want modulus, magnitude of that one. Already this concept we discussed in vectors. In vectors. What is the angle between P1 and minus P2? 180 minus P2. 180 minus P2. P1 square plus P2 square plus 2P1 P2 cos of 180 minus theta. See carefully. The angle between P1 and P2 is theta. The angle between P1 and P2 and minus P1. P1 and minus P2. See here. This is P1. This is P2. This is theta. This is minus P1. This is 180 minus theta. Observe carefully. We want the angle between P2 and minus P1. P2 and minus P1. This is the result. P1 square plus P2 square plus 2P1 P2 cos of 180 minus theta. According to parallel of factors. Then delta P mod S is equal to root over P1 square plus P2 square minus 2P1 P2. Yes? Ready? Next, third application. Suppose this is the wall, rigid wall. This is the body of mass m is moving with initial velocity. After it hits the wall, becomes rest. Becomes rest. The body of mass m is moving straight line with a velocity v1 or v. Finally, it hits the wall, becomes rest. mean final velocity. What is the change in moment?
P1 mv plus I cap. It is moving this direction. P2 is equal to 0. Delta P is equal to P2 minus P2. Delta P is equal to 0 minus mv I. Delta P is equal to minus mv I. Modulus of delta P is equal to mv.
Okay. This is the third equation. Now suppose the same body rebound with the same velocity. What we get?
Wall. This is the wall, mass m, which is moving with velocity v. After hit, the same mass moving with velocity v. This is plus I cap. This is minus I cap.
Rebound with same velocity. What we get?
P1 mv P2 mv minus P. Delta P P2 minus P1 delta P minus mv I cap minus mv I cap. Delta P is equal to minus 2 mv I cap. Modulus of delta P is equal to 2 mv.
Because of momentum is vector, we put in the modulus, getting positive. Bond. Next, suppose in next application, a body of mass m is moving with velocity v1. After hitting the wall, it moving with velocity v2. What we getting? What we getting? P1 is equal to mv1. I can. P2 is equal to rebound. mv2 minus I can. Delta P is equal to P2 minus P1. Delta P is equal to mv2 minus I can minus mv1 I can. Delta P is equal to minus m of v2 plus v1 of I can. Delta P of modulus is equal to m of v1 plus. After putting the modulus, that means either positive becomes positive, either negative becomes positive. So this is vector is gone out after putting the modulus. Next. So this is the change in momentum, fifth application. Now what is the sixth one? Suppose during projectile motion, this is initial, this is final. P initial. What is the initial momentum at origin? At origin. M
ux I cap plus m uy j.
At origin, what is the initial velocity? Ux I cap plus uy j.
P initial mu cos theta I cap mu sin theta j. P final. So m, that is Vx I cap plus m Vy j cap. Maximum height.
At maximum height, final velocity becomes 0. Vy becomes 0. Vy becomes 0.
Vx is equal to ux plus ax into t. Vx is equal to u cos theta plus 0.
Because of along origin direction, acceleration 0. Vx.
Vx is equal to u cos theta. Vy is equal to 0.
0. Final velocity at maximum 0. So final what will you get?
P final is equal to mu cos theta I cap. This is equation number 1. This is equation number 2.
What is change in momentum between initial point, that means at origin, and the highest point, maximum? What is the change in momentum?
P final minus P initial. P final minus P initial.
We get a change in momentum. So after substituting these two values, change in momentum,
Delta P is equal to P final minus P initial. Delta P is equal to P final mu cos theta I cap minus mu cos theta I cap plus mu sin theta j. Delta P is equal to mu cos theta I cap minus mu cos theta I cap minus mu sin theta j. These two are cancelled. Delta P is equal to minus mu sin theta j. Modulus of delta P is equal to modulus of mu sin theta.
okay? The change in momentum between initial point and final point. At origin, at path of maximum height, or maximum. What is the change in momentum between initial point and the final point? Initial at origin, final landing. What is that?
This is initial. This is final. What we do? Final is after landing, it is also two direction. So this is the maximum limit. This is Vx, this is Vy. Initially, it is Ux, it is Uy. What is that? P initial, Mux I cap, Muy j cap. P initial m u cos theta I cap plus m u sin theta j. Question. P final m ux m vx I cap plus m vy j minus j. See carefully. This is plus. This is minus. You don't know direction. Minus. See carefully. Listen carefully. So up plus, down minus. Up plus, down minus. P final. M what is Vx? U cos theta. Okay. Plus what is Vy? M U sin theta of minus. This minus is putting there. This is plus, this is minus. Question number 2. So this is initial momentum, change of momentum, delta P final minus P initial, delta P, m u cos theta, okay, plus m u sin theta, g, minus m u cos theta, okay, plus minus into minus plus minus into minus plus what substitute minus plus m u sin theta. So m u cos theta delta p is equal to 2m u sin theta j. So Vx nothing but ux plus ax into t. We getting u cos theta. Vy is equal to here also. So that is opposite that of uy. Vy is nothing but opposite to that of uy. Vy are both opposite. That's why I putting this is a minus. This is plus, this is minus. These both are opposite. Next. What we getting finally? This is change in momentum delta P bar minus 2m u sin theta. That is another application of change in momentum. Now we go for last application. Again, 2 more applications are there to calculate the change in momentum. Those are calculated some angle. Those are hitting with what some angle. Makes an angle with the horizontal, makes an angle with vertical. What we are getting is the change in momentum. Right. Now see here, when the body of mass m is hit with wall, makes an angle theta with the horizontal. What we getting? Change in momentum. Initial momentum, final momentum. See. This is the wall. This is horizontal. This is the ball. Mass m hits the wall, makes an angle theta, and rebound with the same velocity. This velocity here on velocity makes an angle significant.
What is change in momentum along x-axis, along y-axis? First this one, we have to take this one, or this one. This is Vx, Vx, and Vy, Vx, Vy, for this one. See carefully, Vx, Vy, because of this is like that. This is T2. This is also T2. How much differences? So what is this? Vx. What is this? Vy. Vx, Vy. See carefully. For this one. Vx, Vy. This is Vx. Here Vx is close to y. Vy is minus 2. What we get? P. So that is initial momentum. Initial momentum, that is along x-axis. M Vx cos theta plus I cap. This one is M V. So that is Vx, Mvx, Px. This is Py. Py. M V sin theta minus 1. See carefully. Initial momentum along x-axis. Initial momentum along y-axis. Initial momentum. So this is the initial direction. So initial momentum along x-axis, initial momentum along y-axis. Okay, initial momentum. Next, after that, it is in the way direction, it's the direction. What we get? This is the initial. What is final? Like that. This is like that, this is like that. So that is Mvx, Mv cos theta minus I cap. Mv sin theta minus j. This is final momentum. Final momentum along x-axis, final momentum along y-axis. See carefully. See carefully. What I am saying here, the body is moving in two directions. There are initial momentum along two directions, final momentum along two directions. This is initial momentum, two direction, Mvx, so that is Px. This is the final momentum, two direction. That means Px final, Px initial, Px final. What we get? Final. So that is Mu Mv cos theta minus. So this is P final, P momentum y-axis final, Mv sin theta minus j. This is initial. So we have two momentums. Initial momentum, two direction. Final momentum, two direction. This is initial momentum. This is initial momentum, x-axis, y-axis. This is final momentum, x-axis, y-axis. Already I draw the diagrams for initial momentum and final.
initial momentum and final. This is initial. This is already drawn the diagrams, initial momentum, final. So this is initial momentum along x-axis, final momentum along x-axis. Initial momentum along y-axis, final momentum along y-axis. What is the change in momentum along x-axis? Change in momentum along y-axis. What is change in momentum along x-axis? Here. Change in momentum along x-axis. Px final, Px initial. Final momentum, initial momentum. Those are calculated along x-axis. Delta P x. So Px, what is final? Mu cos theta. Mv cos theta minus I minus Px initial Mv cos theta. Finally, delta Px minus 2mv cos theta. We want modulus vector 2mv cos theta. Okay. Next, change in momentum along y-axis. P. So that is along Py final momentum minus Py along initial. Py final Py along initial. What is P final? P final along the y-axis. Mv sin theta minus j cap minus again mv sin theta minus j. Both are minus. See carefully. This is downward direction minus I. Here also downward direction minus I. This is minus. This is minus. See that this is minus. This is minus. Both are minus. Getting minus into minus plus. Mv sin theta, that is minus j cap plus mv sin theta j cap. These two are cancelled. Change in momentum along the y-axis. See carefully. Already this application previously we discussed. So this is change in momentum along x-axis we getting that is 2mv cos theta. That means body is hit the ball with makes an angle theta with x-axis. We getting change in momentum along x-axis. We getting change in momentum along x-axis. So change in momentum along y-axis becomes 0. Suppose the same body is hit the ball, makes an angle with theta with vertical, we getting change in momentum with vertical direction. Change in momentum along x-axis becomes 0. Just remember. So this makes an angle theta with x-axis we getting x. We getting x value. Y value 0. Suppose changing that is makes an angle theta with y-axis we getting y. Change in momentum along x-axis 0. So this is a comparison. Right. So same diagram I draw, but angle is different. See carefully. This is the wall. This is the body. It's the wall. This is M. This is also M with velocity v. Here also velocity v. This is theta. This is theta. This is the y. What do we get? Change in momentum along x-axis is 2m u cos theta. Change in momentum along y-axis is 0. Okay, done. The same diagram I draw, but different angle. Angle is different. Same body of mass hits the ground, hits the wall, like that. Makes an angle theta with vertical. Angle of incidence is equal to angle of. See carefully. Here this is x-axis, we get x. This is y-axis, there is no angle with y-axis, 0. Here there is no angle along x-axis, 0. Change in momentum along x-axis is 0. Change in momentum along y-axis 2mu sin theta. See, along x-axis cos, along y-axis sin. Suppose there is an angle with y-axis, but we are getting the sin. So this is the way to calculate the change in momentum. So inertia, types of inertia over momentum and their applications also complete. Now we go for Newton's second law of motion. By the using of concept of momentum, we have to calculate the Newton's second. Newton's second law is always tells us, second law tells us force and their applications. Force and acceleration, related force and acceleration. See, Newton's second law of motion. What is Newton's first law? Newton's first law tells us inertia. There is no force, there is no action, there is no change of state. That is called inertia. So, until external force acting on the system on the body remains in state. The body, suppose a rest body is continuously at rest. Motion body continuously in motion up to until the body is acted by external force. Here, in the first case, first law, external force 0. In this one, what is external force? How to calculate external force? External force causes. Here, the external force causes external force acting on the system. What happened? That tells Newton's second. The external force acting on the system, then that external force is, so that is accompanied change in momentum. That is called Newton's second. The rate of change of momentum is directly proportional to the rate of change of momentum, linear momentum. There are two types of momentum, linear momentum, angular momentum. Nothing but angular momentum is related to, belongs to rotational dynamics. Linear momentum, that means straight line motion, 2 dimension or 1 dimension, is directly proportional to external force acting on it along a straight line, always along a straight line.
Okay. Now we go for explanation. See carefully. dP by dt. I draw I wrote the equation according to statement. Rate of means rate measure with respect to time. With respect to time. The rate means with respect to time. In any that is a subject. So that is chemistry or mathematics or that is physics. Rate means with respect. Rate of change of momentum is direct and proportional to external force. The external force proportional to dP by dt. External force proportional to d by dt of, we know that P, mp, we know that. Already I explained previous at the starting of changing application already. This is d by dx of d by dt of mv. So that is a formula. F proportional to m dv by dt plus v dv by dt. The proportionality constant is equal to k of m dv by dt plus v dv by dt. This is the basic formula of electricity. According to principle of homogeneity, do you know principle of homogeneity? So the dimensions of LHS is equal to dimensions of RHS. But K belongs to modulus proportionality constant. F is equal to, this is the first case. F is equal to second case. What we get here? See, in first case, F is equal to K into M into dV by dt. In this one, what is the constant? Mass constant, velocity changes. Mass constant, velocity changes. We know that, what we know? dV by dt is equal to A, acceleration. F is equal to kma. K is equal to 1, what we getting? F is equal to. First case, mass constant, velocity changes. Suppose a body, initially 1 kg body is there. Initially, that is at rest. After hitting the 1 kg body, velocity changes, mass remains constant. Here we can say mass constant, velocity changes. With respect, we are getting F is equal to. If K is equal to proportional. Next, second case, F is equal to K into V into dm by dt. Here, velocity constant, mass changes. Example, suppose a lorry or a truck is moving with constant velocity, velocity constant, mass constant, velocity constant. That is a truck or lorry is moving with constant velocity. A gravel is dropped. Gravel means gravel or sand is dropped onto the track. 1 kg per 1 second, 2 kg per 2 seconds, 300 100 kg per second. So that is 1 hour like that. Here, velocity. The body which is maintaining constant velocity with variable mass. The body which is maintained with constant mass with variable velocity. See carefully. Both are equal. Both are important. Now, F is equal to K into V into dm by dt. If K is equal to 1, what we get? F is equal to V into dm by dt. Equation number. So this is equation number 1. This is equation. Suppose the external force acting on the system to maintain constant velocity. What is the acceleration to maintain the constant velocity? Same body. What is the acceleration of the system to maintain the constant velocity? Variable mass. So this F is equal to ma substitute here. We get in. So that is the acceleration. Fourth one. But F is equal to ma. V into what we get? A is equal to V by M into dm by dt. To maintain constant velocity, See carefully. Velocity constant, there is no acceleration. There is no acceleration. So you remember that equation. But here, mass is variable with respect to time. Mass variable with respect to time. To maintain the constant velocity, the acceleration of the system must to push the lorry, to pull the lorry. So it is moving with the force, that force in terms of acceleration. A is equal to V by M. Here, velocity constant, but acceleration is not equal to 0. So see carefully, listen carefully. This is, so there is one example to, that is calculate the difference between acceleration and the constant. I told you. Right. This is about Newton's second law of motion.